You can ask somebody what the blanks were. You can come ask me what the blanks were, or you can look at the video that I'm recording. Oh gosh, there's another one. Or you can go on Canvas and I have the completed slides posted. I don't have them. So that's kind of all that. I wonder if my little finger's dead. No? Ah, it's not plugged in. So this first bit, basically kind of want to talk about these physical sciences and where they're at on the food chain. We'll see how far we get if we get through this whole part. If we don't get through this little packet of lecture slides, we'll pick up here on Wednesday. How's that sound? So now you can kind of see what the three blanks are along the top. I have a fellow faculty member who teaches psychology, and he keeps calling, and we'll talk about what a pseudoscience is, but he keeps calling like these physical sciences are pseudoscience. The word pseudo meaning kind of like not real. But his actually humanistic, sociology, and psychology fall under, they are science, but sorry. So what would be formal sciences? Like you can see, you're talking math and logic. Humanistic would be my friend, the psychology teacher, okay? And we're going to talk about hallmarks of science. One is that they follow the scientific method of discovery. We'll kind of talk a little bit about that. And of course, here we are. There are different ways to chunk up natural science, okay? Maybe some of you guys have taken a biology class, okay? But one good way to just chunk up natural sciences would be physical science versus biological science. Now, I almost go overkill on my slides. I was getting ready for lecture and I'm like, really? Do I have to say that again? So some of these I feel like are kind of early on redundant. So over here we have another way to chunk up science, just simply two segments, behavior and social. And then over here under natural, you can start to kind of see some of these words, okay? So under natural, again, biological, physical, and what do we have under physical? Dun, dun, dun. Let's see, which one are we missing here? Anybody tell of these four? What's listed on the board that we're going to do, but not listed there? The M1? The M1, meteorology. The M1 is the same thing as weather. Yep. They're all good, so I'm curious to see what you guys want to start with. I mean, dang. So anyway, yep. So meteorology isn't listed there, but it's listed on another one coming up. Again, sciences, we have social sciences, natural science, biological, physical sciences. And then here we actually pick up the M1. We always actually pick up meteorology. Geology would be like earth science. And notice like NASA, the whole alien thing. So NASA are the study of space and Earth's atmosphere and all that. That's kind of balled up into astronomy, meteorology, and geology. If I go too fast, let me know. Because I can go back with a click. Now, this actually gets to the point why in the past, in my defense, I've actually kind of gone in this order that you see them listed on the board. It's kind of what we say the hierarchy of science. But I got to thinking, and actually they're pretty independent how I teach them. So logic first, followed by math, followed by physics, followed by chemistry. And then after chemistry, all sorts of things open up. Only after you kind of talk about chemistry is like atoms and molecules and all that stuff. When we're talking about atoms and molecules and that sort of stuff, can you kind of talk more about biology, nanoscience, xenoscience? So I just thought it was, again. What else we got? All right, now we're switching gears. There are some terms in the scientific method of discovery, the scientific method of understanding things. Like you probably heard of the word hypothesis, you're going to see it here. You heard of the word theory, you're going to see it here. Those are hypothesis comes before theory. How do they fit in? Well, in the scientific method of understanding how things work or discovery, we have observations, okay, and based upon our observations, we ask a question. Curious which one's on? Based upon our question, we're going to kind of come up with, we're going to propose a hypothesis. And hypothesis? A hypothesis? I don't know, I'm not an English major. So sometimes we call this our best guess, okay, hypothesis. And it's consistent with what we've observed. Based upon our hypothesis is how we think things work, okay? And we're going to test it. I guess you have a little blank there. We're going to test our hypothesis. Have all those words, test hypothesis. And we have a couple of things. Now, by test hypothesis, actually, that's the word that we experiment. That test hypothesis, experiment, same thing. We have two possible outcomes. One is that, you kind of see this pink. One is that actually our experiments make sense. Our experiments prove we were right, okay? So then we're gonna keep going down that road. One of the things that this doesn't say is that if our experiments prove that our hypothesis was right, we're not done yet. We gotta come up with some more experimentation and that sort of thing. Basically, you do it till you're convinced you're not wrong, because you don't want to be embarrassed when you go ahead and tell the rest of the world your hypothesis. Another possibility is that our experiments showed that our experiments showed something we weren't expecting. It happens. I say in the lab, if you get weird data, be proud of your weird data, because maybe it's right, okay? But if your experiments say something different, then you actually, this says reject the hypothesis, modify the hypothesis, or reject it is probably more accurate. So you don't have to start from the starting part. Another way to kind of look at the scientific method of discovery. Again, this is kind of similar to what you saw before. Which one did I take out here? Okay, so ask a question, do background research, and come up with a hypothesis. There on the left says, test with experiments, analyze your experimental results. If your hypothesis is false or only partially true, then you have to go ahead and revisit your hypothesis. Modify it, throw it out, get a different job, go into basket weaving, okay? If your hypothesis based upon your experimental results is true, if your experimental results are consistent with your hypothesis, then you're about, and again, this is a little bit early. This thing down here, peer review, you don't want to be, you don't have egg on your face. So, but peer review is usually done in publishing in journals, scientific journals of that type. Okay, so each one of these would have their own set of scientific journals. Years ago, before printing, and now I don't know how the internet kind of fits into all this, but before printing, this is a story about Isaac Newton, I want to say, when he had gathered data and he wanted to tell the world what his hypothesis, for instance, was about gravity. He would and they didn't have printers then, so he would write it longhand and he would put it on a tree. I guess he put it on a tree where there's a lot of traffic, okay? But anyway, so that's the way you get the word out then. All right, again, the scientific method. Let's see, which ones do you have? Hold this one. What do you think? What do you think that first one is? It says use observations to create or modify hypothesis. It's going from left to right. Deduce blank to make predictions. What do you think the word is? Deduce from something to make predictions. Deduce from hypothesis. Well, I suppose. Seems like weird wording for that. What do you think the next word is at the bottom? It's going to kind of go in a clockwise. What's this word down here? Test blank by designing experiment.
Predictions.
Very good. Test predictions. Ding, ding, ding. All right. Going to go on. Perform blank and characterize observation. What do you think?
Experiment.
I think so too. Very good. On the next one, I can't have too many slides. What is, oh, it's already there. The word, I don't know if you can see it very much, but I haven't said it yet. Or maybe it's a theory. This is the word theory. So kind of last we left with this idea of applying the scientific method of discovery based upon observations, experimentations, an initial hypothesis, and you do a lot of experimentations, like a loop. If you do that a lot, you publish it in a journal, and your peers are like, oh, that's pretty cool, but they probably won't, because peers, scientists are like little kids, they like to shoot you down. So you probably have a bunch of scientists saying, I don't think so. But if they can't poke any holes in it, okay, if it stands their scrutiny, then it can be elevated to a theory. So that's a big, hairy deal. I kind of liken it to if you're playing checkers. I used to say chess, but that's wrong. If you're playing checkers, you know what happens if you get from your side to over your opponent's side. What happens to your piece?
You get king.
You get king, yeah. So a theory has started out as a hypothesis and made all the way across without getting jumped or taken or whatever, and it's been king. One of my pet peeves, and I've probably done it before too, is it's just a theory. Like, dude, if it's a scientific theory, that's no small feat. Okay, all right, and then this is the last one. Let's see. We start with observations, then we come upon a best guess hypothesis. Experimentations, do we see if a hypothesis was right? And that could go one of two ways. And then it can be elevated to a theory if we've done all due diligence and our peers agree. Okay. That last word right there is a law. Okay, notice that in this flow chart, I have like a little break there. A law is unbound by itself. For instance, there are a set of laws, and they kind of intersect in physics and chemistry, a set of laws that say how gas behaves, gas laws. You guys know what some of these are. What happens to a balloon that's inflated, and your balloon is in your cold car? What happens to it? Does it shrink or expand? It deflates, yeah. That's because gases are behaving like that, you know. And that's because the gases that we're making are all kind of inflated are slowing down. They're like cold lamps. And so those gas particles don't make it inflated as much. So gas laws, okay, gas laws. Law of gravity. There's so many different laws, but those are fundamental to just the way things work. And those won't undergo hypothesis and theory. Those are like tools that you can use when you're up in the scientific method process. All right. So the word the suffix, the end of a word ending in O-L-O-G-Y, O-L-O-G-Y means to study up. And I'll tell you one of the things that and it's okay, but I got these, aren't these fun? I tell you, teaching is so fun. Astronomy, all right? This is a science. Astrology. Okay, this is not science. It's an interesting sort of thing. Why isn't astrology a science? What is astrology?
Because it's a study.
It's not a study. Yeah, astrology is not. Well, it's kind of a study. Astrology is horoscope. It's horoscope basically. I don't know much about it, but I think it's interesting. I've looked at my horoscope. Astrology. The reason it's not a science is because, and I kind of have this to say what isn't a science. It fails being able to, it's not really testable. Like, I think it's testable. You can look at your horoscope and then see does that come true or not. But it's not really a science. And sometimes people will take this class, I teach physical science. I also teach intro to astronomy. And sometimes people say, oh, I took astrology with Mrs. Snubbs. I'm like, no, you didn't. But anyway, so astrology, and this kind of, you're like, well, how come it got the ology? How come it got the ology suffix? And my thing is because it was there first. Astrology is a long-standing, and I'm not to say that astrology isn't kind of an interesting and kind of developed people's appreciation for that kind of stuff. So we would call astrology a pseudoscience. Pseudosciences don't apply the method we were just talking about. And they don't have hypotheses or theories that can solidly be tested. But we do have some, you're going to see them here, listed here. We do have some other pseudosciences that end in the ology, and sometimes that throws us off. Now, I'm not saying that these things don't interest me. Numerology, how numbers affect your lives. Astrology, anybody know what cryptozoology is? It's like Bigfoot. And it's like the animals, zoology, like the imaginary animals. But I watch those things on Bigfoot. I do. Ufology, like study UFOs. Okay. Carl Sagan was. Remember, I said that our modern, an old-time version of Neil deGrasse Tyson. It just says the statement there is just. Be careful of the whole pseudosciences. They're interesting to me, they're intriguing to me, but don't be swept away by the pseudosciences. So what should we be looking for to see if it's a science? Let's see what I took from these words. Oh, I don't have this one, do I? Or did I move it? Well, I might have to print that one off for you, especially if I have a test question that comes from it. So just kind of watch this one. Have you ever heard the keep it simple, stupid? Okay, the KISS principle. Basically, the more you have to kind of weave a story of within your hypothesis, weave a story of how things work, there's a good chance that you're off base. The simpler the better. Keep it simple. So that's one's right here, keep it simple. This one says that your science needs to be testable. If you make a science that you can't really test, then it's not science, it's a pseudoscience. The last one says that in your hypothesis, what you're trying to elevate to a theory, the only explanations you can use are natural ones. Of course, the opposite of natural would be supernatural. You can have those supernatural ideas and beliefs, but they don't fit into science. Okay. Then you guys do have this one. So, we'll be dealing with a little bit of numbers, especially in these first two units, but don't be afraid. Don't be afraid. We'll be fine. When we deal with all sciences. Now, even though I took the numbers out of these, astronomy and meteorology and earth science, and there's no numbers in there. Do you think that do you think that there are numbers associated with those? Yeah, there are numbers. But I took them out. But we need to be able to make measurements in physical science, in all science. And let's see what blanks you need to fill in. Looks like I have kilogram. kg is measuring mass. I should have asked you guys the answers to these, what you thought, I guess. Temperature in Kelvin, and the symbol for Kelvin is the capital K. And that's about it. But this is kind of a nice summary of science is just, it makes me smile. So, one of the things about science is if I were to have a globe here of the Earth, science is got to be kind of consistent. You can have a scientist here talking in the United States, talking to a scientist in China. Unlike politicians, I believe scientists get along a lot better. Okay, so we need to be talking apples to apples. So these are the standard units of measurement. Back in 5th grade, I remember my teacher, and then you have a teacher that teaches lots of different things. I don't know if it's math or science, but she said, listen up, because when you guys are adults, you will be getting your gasoline, not in gallons, but in liters. It's like, oh yeah. Liters, of course, is a metric sort of deal. We have milliliters, kiloliters, you know, we have liters as a basic unit. So anyway, I'm still getting it in gallons. I don't know where that teacher is. But you need to know these prefixes. Okay. If you would, see if my pen works. So kilo, I'm going to go ahead and find kilo. And that's 1,000 times. Centi is 1/100th. Maybe I bet you guys already know this. Like a penny is a cent. So 1/100th. That one's down here. Milli is 1/1000th. That one's right here. And micro, the symbol for micro is, let's see if I have it down here. Nope. Drat. The symbol for micro, how could you have two M's? That is just dumb. This symbol for micro is not an M. It's called the Greek letter mu. It looks like a U with a kind of a long tail. So if you would fix that, that would be great. Micro is this one. And that's 1/1,000,000th. And the symbol is mu. How we do? I'll put up against the time. Okay, good. Well, that's a good place to stop. You can see the last part, and this will be good. You're like, oh, Mrs. Snipes, it's numbers. You'll do fine. Because one of the last things I want to do, and there's a lot of times students come in and already kind of know the scientific notation, but we need to kind of hit that a little bit, even more before we do astronomy especially. And kind of, we have some big numbers in astronomy. So we'll start here on Wednesday, and I'll also give you another sheet according to what you guys want to do first. Okay, so any questions? Are you guys set? Okay. No sign. Okay.